Hello Bobcats. So in this video we're going to talk about molecular geometry. This is called molecular geometry notes. And the shape of molecules occurs because of what we call the VSEPR theory, which stands for valence shell electron pair repulsion. So electrons will arrange themselves to minimize repulsion. In other words, they want to be as far away from each other as they can possibly be, so they will form bond angles so that they can be apart from each other and minimize that repulsion. We're going to go through, I call them families of different molecular geometries. And as I go through this chart, you'll see we have a formula. We'll do the dot structure. Then we have electron domains. That electron domains are anytime there are going to be electrons found in bonds or lone pair electrons. Then we have bonding domains. That's only where we find bonds. Then electron lone pairs. Then we're going to look at the electron geometry. Electron geometry includes all of the electron domains, whereas molecular shape only includes the bonding domains. Then we'll talk about hybridization and bond angles. So the first one we're going to look at is beryllium chloride, BeCl2, beryllium chloride. And let me draw that a little bit better. I can do a better job than this. So beryllium chloride. And so we're going to put the beryllium in the center. Then we'll have chlorine. Now, in this case, so I can save space, I'm not going to show all the lone pairs around the outside. I'm going to show it this time, but it's going to be understood that the lone pairs on the outer atoms are there. We're just not going to show them always. And we're really looking at the central atoms for the shapes. Now, if I look at electron domains around the central atom, we've got 1, 2. Those are electron domains. So there's 2 electron domains. We also have 2 bonding domains. So 2 bonding domains. And then the center atom does not have any lone pairs. Now, what this looks like is I have the molecule right here. So I have beryllium chloride, where this is beryllium. I have 2 chlorines, and then I have the bonds here. And you can tell that it's linear. It's one line. And the distance between this bond and this bond, it's a 180-degree angle. Now, so this is called a linear molecule as far as electron geometry based on electron domains. And then the molecular shape is also based on bonding domains, so it's going to be linear. And it's hybridized. Remember, 1, 2, so it's going to be an sp hybridization, 1, 2, and then the bond angle is 180 degrees. Okay. Now, we can have different ways of getting linear molecules. This is carbon dioxide, where we have a double bond carbon, double bond oxygen, carbon, double bond oxygen. But if you'll notice, we only have 2 electron domains, 1, 2, 2 bonding domains, 1, 2, around the central atom. And there are no lone pair electrons. So this is a linear molecule. So we can do it that way. We can also make linear molecules. This is ethyne, where we have a carbon triple bonded, 1, 2, 3, triple bonded to a carbon. And if you look at it, and we're just going to look at one carbon, this carbon has 1, 2 electron domains and 1, 2 bonding domains. And so this carbon is sp hybridized, and this is also a linear molecule. So we can have different ways of producing linear molecules. Now, that family only has 1 member to this family. So I'm going to draw a line here. And you can call this the linear family or the sp hybridized family. I'm just going to write sp hybridized family over here. It's the sp family. But it's also known as the linear family. Now the next one we're going to look at, we're going to look at boron trihydride. And so it's going to be a boron in the center with a hydrogen, hydrogen, hydrogen. Now look at it, it's got 1, 2, 3 electron domains, 1, 2, 3 bonding domains. The central atom does not have any lone pairs. And so what kind of shape do we have here? So here is a boron trihydride, boron with 3 hydrogens. And if you'll notice, it looks like a triangle. So there's a triangle and it's in a single plane, right? It's not three-dimensional, it's just 2 planes. So if I have this, then we say that this is trigonal for the triangle, trigonal planar, because it's on a plane. Now, because the bonding domains are the same as the electron domains, it also has a molecular shape that is trigonal planar. And when we have 1, 2, 3 bonding areas, or electron domains, I should say, it is going to be sp2 hybridized. So it's sp2 hybridized. And if this is 360 degrees, the greatest angle would be 120, 120, and 120. So this is 120 degree angles from here to here. Okay, now there's another member of this family, and we will look at it. Let's look at SO2, sulfur dioxide. So we have the sulfur, double bond oxygen, single bond oxygen, and then there's a lone pair here. Okay, so remember, we're just looking at the central atom. I'm going to draw a little orbital for that lone pair. And as far as electron domains go, we have 1, 2, 3. The lone pair is part of the electron domain, so we have 3 electron domains, and we only have 1, 2 bonding domains. This is not a bonding domain. There's no bonds there, so that's 1. This is a domain, and this is a domain. So we have 2 bonding domains and 1 lone pair. Now, the electron geometry is based on electron domains. Since there's 3 of them, it stays the same, trigonal, planar. But now the molecular shape is going to be different. So here we have SO2, where we have carbon or sulfur double bonded to an oxygen, see the double bond, and a sulfur single bonded to an oxygen, and then we have our lone pair up here. So you can see the trigonal planar. It still has a triangle, but when we look at molecular shape, we do not look at the lone pair, we just look at the bonds. And so in this case, it's a bent molecule, because we don't look at the electrons, the lone pair, we just look at the bonds. And so that's a bent molecule, so we can say it's bent. Okay? And it is also sp2 hybridized, because hybridization is based on the electron domain. Now, the angles, it's going to be less than 120. There is no hard and fast rule. They have to be measured. But generally, you can kind of think of it as losing 2.5 degrees of angle for every lone pair, because what happens is that lone pair pushes these angles closer together. So it's about 117.5 degrees. Now that's not exact, it's just a trend, a pattern. And I'm going to write about like that, so you know it's about. So that is all there is for that family. So the sp2 hybridizate family, the sp2 family, or you can call them the trigonal planar family, has 2 members to it. So that's the sp2. So now we have those done, and now we're going to look at the sp3, and it's going to have 3 members. The first one we're going to look at, excuse me, is methane. And so it's going to be a carbon. And the way we draw it is that you draw a hydrogen up and then a hydrogen at an angle. These two are in a plane. Then I'm going to draw a wedge. Now the wedge means that the hydrogen is coming out of the plane, and then we're going to draw a dotted line, and that dotted line means that the hydrogen is going back into the plane. So what it looks like is it looks like a tripod with a hydrogen sticking up. And so what we have here is my trigonal planar. If you'll look at it and see if we can do this, we have I may need to get a flat surface. And so you can see the tripod in the bottom with the hydrogen here, okay? And the way it's drawn is I've got these two are in the plane. This one's coming out, that's the one with the wedge, and this one is going back, that's the one with the dotted line. So in this case we have 1, 2, 3, 4 electron domains, and 1, 2, 3, 4 bonding domains with no lone pair. And the name for this is tetrahedral. Tetra meaning 4, hedral meaning sides or faces. And if you can look at this, I have one side here, one on this side, and then one on the bottom. So that's 4 sides. 1, 2, 3, and then the one on the bottom is 4. So tetrahedral. Since these two are the same, it also has a tetrahedral molecular shape. Now it's hybridization, it's 1, 2, 3, 4, so that's going to be sp3 hybridized. And the angles that you have here is 109.5 degrees. The next one we're going to look at is ammonia. So it's NH3. So I'm going to have an N with a hydrogen in the plane, a hydrogen coming out, and then a hydrogen going back, and then we have our lone pair up here. Okay, so we have 1, 2, 3, 4 electron domains, but 1, 2, 3 bonding domains and 1 lone pair. Now every time you add a lone pair, you actually change the molecular shape. Now since the electron geometry is based on the electron domains, it's still 1, 2, 3, 4, so that's tetrahedral. And let me show you what that looks like. So here we have ammonia, and you can see the lone pair there. And what we see is that as I turn this, you can see there's the 3 here that kind of make this tripod that you see here. So if I were doing this, we have this is in the plane, this is coming, well, let me put it this way. We have this one in the plane, we have a hydrogen coming out and a hydrogen going back, and in the lone pair. And so when you look at this, if we don't have the lone pair and we're just looking at the bonds for the molecular shape, it looks like well, the tripod there, let me show you with this. So if we look at it like that, we got a tripod, and it looks like a trigonal pyramid. So the shape, molecular shape, when you have 3 bonding domains in a lone pair, is trigonal planar. Pyramidal. Trigonal pyramidal. Trigonal because it's got the 3 at the bottom, a base of 3, and then pyramidal because it looks like a pyramid. Trigonal pyramidal. And again, it's 1, 2, 3, 4 electron domains, so that's sp3 hybridized. And it has about an angle of 107 degrees. Now, to let you know, a lot of books and tests will just say that they all have 109.5, but honestly, they do lose some angle as you gain lone pairs. And then the last one we're going to look at in this family is H2O, water. So we have an oxygen, hydrogen, hydrogen. We have a lone pair here and a lone pair here. And so there's the orbitals for the lone pairs. Now this one's a little hard to see when I draw it, but I'll show you in just a minute. We have 1, 2, 3, 4 electron domains. Remember, bonds and lone pairs make up a domain, electron domain. We only have 1, 2 bonding domains, so this is the bonding domain group. So we have 2, and then we have 2 lone pairs. So we have 2 lone pairs. Now, remember, electron geometry is based on electron domains, and since there's 4 of them, it's tetrahedral. Now, this though, remember, when we look at the molecular shape, we're only going to look at the bonds or bonding domains. And so let's look at water real quick. So here's water. We've got the 2 hydrogens, and then we have a lone pair and a lone pair. And if I put it down, you can see that it's still tetrahedral, right? You can see how the tetrahedral shape shows up, the same as this one up here with the lone pairs. But when we take the lone pairs off, what we have is a bent molecule. So now, because there's only 2 bonding domains, this is a bent molecule. It's still sp3 hybridized because of having 4 electron domains, and the angle is 104.5 degrees. Okay, so let me review this real quick. In this case, if you have 2 electron domains and 2, or with 2 bonding domains and no lone pairs, it's linear. And because there's a 2, it's sp hybridized, 180 degrees. That's in one family. You can call it the linear family or sp hybridized family. The next one, we have 3 bond electron domains, both of them, this one here, and this also. It's got an electron domain here, electron domain here, and electron domain here with the lone pair. So they both have 3 electron domains. This one has 3 bonding domains, 1, 2, 3, and no lone pairs, and this has 2 bonding domains and 1 lone pair. The electron geometry is based on electron domains, and that's going to be trigonal planar. They're both the same, but every time you add a lone pair, it changes shape, and now this is bent when we only look at the bonds. You can see the bent shape right there. And then it's sp2 hybridized. Both of them are sp2 hybridized because it's based on the 3 electron domains. Then we have our sp3 group, or our tetrahedral group. So remember, you can call this the trigonal planar group or sp2 hybridized. Here we have sp3 hybridized group or the tetrahedral group. And again, when you have 4 and 4 with no lone pairs, both the electron geometry and molecular shape are tetrahedral, sp3 hybridized. Here we have 4 electron domains, but now we only have 3 bonding domains and 1 lone pair. So the shape now is trigonal pyramidal, and here we have 4 electron domains, but only 2 bonding domains with 2 lone pair. And so electron geometry is still tetrahedral because there's 4, but now it's bent because we only look at the 2 bonds. It's still all sp3 hybridized, and then these are the angles. Now remember, on tests, a lot of times they'll just ask you, they just want you to know the first angle, not the others, because these are not exact. These are about those angles, okay? So a lot of times they'll just ask you to memorize the first angles of a group. And that is the first 3 families or groups of molecular geometry shapes. And that's part 1, and I'm going to go to part 2 in just a minute and do the other 2 families, the sp3d and sp3d2 hybridized families. See you again, or see you next time.